It was a draw as a higher current. So data starting must be used for the spark machine. So that when you start as a induction motor usually draw a higher current from the supply. So this current needs to be reduced. So this is where that we have to utilize the reduced voltage starter. So reduced voltage starter can be either star data starter or the auto transformer starter. So this is where we can use for the square induction motor. So today I give you the way to start the square induction motor and the basis circuit for the reduced voltage starter. In the meantime, we also utilize the slip-ring induction motor. Slip-ring induction motor is a roll rotor motor. So there will be the two winding, stator winding and the rotor winding. So stator winding connected to three-phase supply and rotor winding is connected to slip-ring. Then the slip-rings are connected to the external resistance. So that at the starting time, all the external resistance should be short circuited. So motor will be started. And then the motor is started. Then we gradually reduce the resistance in the slip-ring. So by this way, the motor speed can be regulated. So this is ways that we can start this induction motor. So the both square induction motor and roll rotor motor starting method. So I will outline. And then I will also solve the problem for the starting time how the torque are affected. And then I will give you the automatic starter. So today's lesson we focus on those aspects. This is for the starting method. So motor we connect the starting like this. So that at the starting time, this was this way. This way is connected to this terminal. This is two positions. This way can connect. So this is the position 1 or the position 2. So when at the starting time, we connect to the position 1. So this is the middle one. This one, this can be like this. This is position 1 and this is position 2. So position 1 is connected for the star, position 2 for the delta. So this way the starting time are joined to the position 1 at the starting with the start with the star. And running time this will change to the delta. So A2, B2, C2 are the steps. The main supplies are connected. So we can use the starter by the starter circuit we can utilize to the control the starter. So at the starting time, theta is start connected at the starting time. So apply voltage reduce to the 1/2 die. Line current reduce to the 1 die. Starting torque is reduced to 1 die. At the running time, motor winding connected to delta. So that kind of motor starter is useful for the high voltage and high power motor. Direct online starter we apply the full line voltage. So they are only suitable for the 2 kilowatt or less. So this is for the starter is more useful for the higher power motor. Another one is the auto transformer starter. Auto transformer starter means that we can reduce the voltage. So at the starting time we provide the reduced voltage to the motor, and when the motor speed up, we get supply to the we can change the full voltage. So this is the auto transformer starting method. So and these are 3 steps. So that will be the 40, 60 or 75% of the line voltage is applied for the starting, and then motor is run up to speed. The A switch directly to the main. So this is for the auto transformer starting. So I give you the note and the diagram. Starting switch it should be connected to the 1 position at the starting time. So this means that this is supply voltage. So this is the supply. So this is for the motor theta. So this is for the motor. The supply voltage is coming here, but only reduced voltage supplied to the motor. And running time we bypass. Bypass means that this switch will supply voltage and there's motors theta are directly connected. So this is for the reduced. So the reduced voltage at the starting time and the full voltage at the running time. So this is we use the auto transformer starter. So starter and the auto transformer starter are the reduced voltage starter to provide the reduced voltage starting for the last motor. And also we utilize for the wall rotor motor. The wall rotor motor called the slip rim. Those rings are connected in series with the motors rotor also called the winding. So that all slip rings need to be short circuited at the time of the starting. And then when the motor is speed up, you can adjust the resistance. So adjust the rotor resistance. By this way, you can regulate the motor speed. So the slip ring machines are started by the means of the external resistance. So those are the slip rings. So this is the external resistance. So slip ring machines are started by the external resistance. So the through the slip ring to the rotor circuit, the machine is started with the all resistance in. So this means the all resistance are cut off so that the slip rings are short circuited. So short circuited motor will start, and when the machine is so in this case we can provide a high starting torque, and when the machine runs up to speed, the external resistance is reduced until the machine attains a full speed. So this is what we can utilize for the slip rings motor, induction motor. So this is what we can utilize. So because of this one, we can only calculate the torque at the starting by the formula. So normally the machine characteristic we can study the machine characteristic. The horizontal is a torque, and the vertical is a speed slip. So this is torque and the slip characteristic of the machine. So in this case, we can draw as a torque and slip characteristic. So this is for the torque and slip characteristic. So when the rotor resistance is RI decrease, and so we can also follow the slip characteristic. We follow this way. So this is for the torque and the slip characteristic. So sometimes motor can get the crawling. Crawling means when the machine is sometimes fluctuated. So this is the speed, and this is the torque. So when you start the motor is firstly we increase the speed. So when the speed increase, torque increase, and then instantly the torque and speed will go down and we go like this. So this is we call it crawling. This would be like the crawling. Normally motor should start by this way, dotted line. Motor should go by dotted line, but sometimes although you increase the speed, torque will be going down. Especially that kind of situation can happen when the motor is start with a very heavy load. When you start the motor with a very heavy load, it can happen in this situation. So this is a crawling. Crawling increases instability of the machine's operation. So machine can be vibrated. So this is for the crawling characteristic. So we need to avoid the crawling. Normally the machine should follow the dotted line. When you start the motor, we should allow the motor to attain the full speed. After that, you should put the load. So if you allow the motor to attain the full speed and you put the load, so motor will start from dotted line and go to this way. And sometimes what happens is that you put the load without allowing the motor to attain the full speed, and then you put the load. So that way, load is heavy, so it will cool down. And we could flow like this. So this is we call it crawling. The crawling can happen in the car motor with the heavy load starting. So this can be the motor will be vibrated. And then I saw the one problem for the motor starting. A three-phase induction motor has a stator resistance bar phase of the 0.5 ohm, and the rotor resistance referred to the stator is a 0.5 ohm. And then the total sensitive reactant bar phase referred to theta is 4.92 ohm. So this is the R and the RS, AS are already given. So in this case, theta resistance RS is 0.5 ohm. And total sensitive reactant referred to theta is 4.92 ohm. So this is AS plus 8R is equal to the 4.92 ohm. And also the R1. So R1 is also given as 0.5 ohm. So those are given. the ratio of the maximum torque to full load torque is 2:1. So this is also given. Maximum torque to full load torque is a 2:1. Then we will full load torque is equal to half of the maximum torque. Full load torque is equal to half of the maximum torque. So they are given in the problem. So we have to calculate the final ratio of the actual starting to full load torque for the die starting and started starting and the auto transfer starting with a depth of 75%. So firstly we have to calculate this out. It's given the full load torque and the maximum torque. So we will write it down as equation for the maximum torque. So this is the equation for the maximum torque. Maximum torque. So this is a common equation for the both generator and motor. The maximum torque is equal to the 3Vs squared. Vs is the speed of body square divided by 4 pi and 0. And 0 means that starting the speed and multiply with 1 divided by square root of Rs squared. So that this is plus 8s plus HR square and plus or minus R1. So this is the equation. And for the motor action, you have to use the plus. Generator action, the minus. So the plus for the motor action. And then minus for the generator action. So in this case, we are using the motor case. So therefore, the P maxima is equal to 3Vs squared divided by 4 pi and 0 multiplied with 1 divided by square root of Rs squared plus 8s plus HR the whole square plus R1. So this is the equation to calculate the motor's maximum torque. Okay, so in this case, K, the constant. So this is as 3Vs squared divided by 4 by n 0. So 3 divided by 4 by n 0 is constant. So this is constant. So we just put the K. So 3 divided by 4 by n squared is a constant. So that we got the equation T maxima is equal to K into Vs squared and 1 divided by Rs squared square root of Rs squared plus 8R plus 8S squared plus R1. So this equation we got. So then in the problem, Rs, 8S and 8R are already given. Rs is 0.5 ohm, the cylinder resistance, and the cylinder resistance the power is a rotor resistance value also is 0.5 ohm, and 8S and 8R combination is 4.92 ohm. So those things you substitute. So by substitution, what you got is a KVS square and multiply with square root of so 0.5 square plus 4.92 square plus 0.5. So those things we got. So that by solving this one, you got the thing is a KVS square divided by 4.94. So this is a T maxima. Okay, so then you can also calculate about the full load torque. Full load torque. So this is the half times the T maxima. So then we will half multiply KVS squared divided by 4.94. So then we will KVS squared divided by 9.89. So this is the full load torque we got. Okay, so then we have to utilize the starting method. So direct starting. So direct starting is we can utilize the equation. So this is for the maximum torque, the equation. And then we use all the starting method. So the starting condition, the torque we can calculate. So starting torque. So starting top equation is T is equal to 3Vs squared divided by 2 pi and 0. And multiply with split multiply RR dash. So root resistance of the part is theta and divided by split multiply RS plus RR dash square plus split square into AS plus HR dash square. So this is the equation to calculate the starting top. Starting top you can calculate the formula is 3Vs squared divided by 2 pi and 0 multiply SRR dash divided by SRS plus R dash square plus S square into AS plus AR dash the whole square. So this is the starting top. Okay, so starting top you can calculate for the equation. So this is 3Vs squared divided by 2 pi and 0. So split starting equation to direct starting. So direct starting is a starting equation S equal to 1. Direct starting. So split is equal to 1. So the depth saturation, we substitute split is equal to 1 multiply RR dash is 0.5 divided by split is equal to 1 multiply 0.5 plus RR dash is 0.5 the whole square plus 1 square multiply 4.92 the whole square. So this one we got the stock. So this is for the stock we got. So this is for the starting top. So CSD you can calculate. So there will be 3 so Vs squared by 2 pi and 0. So that one is you calculate. So that will be 25.2. So this becomes 25.2. Okay, so now you see the things are K value. K value is we substitute K is 3 divided by 4 by and 0. So this is for the K value. 3 divided by 4 by K0. So now there's 3 divided by 2 by and 0 is this is a 2K. So we call it 2K. So this is for the this one is 0.5 divided by 25 by 2. So that will be 3 divided by 2 by and 0 is equal to 2K. So whole thing is equal to 2K. Into Vs squared, so multiply 0.5 divided by 25.2. So this will be K divided by 25 by 2. So this is the starting top. Okay, so now we make the comparison. Full dot equation is equal to KVS squared divided by 9.89. Standard dot equation is that KVS squared divided by 25 by 2. So we make the comparison. These are starting dot, direct online starting dot, DOS starting dot, divided by full load dot. So the direct online starting dot is the starting is KVS squared divided by 25 by 2. And full load starting dot is we already calculate K PS squared divided by 4 by 94. Thank you. This one is calculate. So this is a K PS squared divided by 25 by 2 multiplied with 4.94 divided by K PS squared. So that's to get me the ratio. That will be 0.4. So this means that direct online starting dot and the full load dot, the ratio is 0.4. So this is for that we can get the direct online starting situation. Okay, this problem is a spiking induction motor. So resistance are given, inductance are given. So that we have to make the calculation. When we make the calculation, the ratio of the maximum torque to the full load torque 2 is to 1. So that the motor can be started by the direct online starting, starting and auto transformer starting. So we have to determine the ratio of the starting torque to full load torque. So firstly we can calculate the maximum torque. Maximum torque equation is 3Vs squared divided by 4 by n0 multiplying 1 by Is squared plus As plus AR the whole square plus or minus R1. So plus for motor and minus for generator. So by solving this one, so we substitute the motor resistance, motor rotor resistance, and the motor reactance you calculate. So that, and also that 3 divided by 4 by n0 is a constant K. So that by this way that you've got the first equation that T maxima is KVS squared by 4.94. So according to the problem given that then full load torque is a half of the maximum torque. So that way we say that full load torque is half multiply T maxima, so that KVS squared by 9.89. So this is the first equation. And then we calculate for the starting torque. So starting torque equations are we use the formula. The formula for the starting torque is TSD is equal to 3VS squared divided by 2y and 0 multiplied with split multiplied R dash. R dash means the rotor resistance of part of theta and divided by SRS plus R dash square plus S square into AF plus TR dash square. RS means the theta resistance, AH is theta inductive reactance, HR dash is the rotor inductive reactance of part of theta. So those values are given. So that at the starting condition, the slave ever 1. So you substitute slave 1 and R dash RS value you substitute. And then you got the TSD. TSD is a 3VS squared divided by 2 by and 0 multiplied by 0.5 divided by 25 by 2. So in this case, the 3 by the 2 by and 0 is equal to the 4 by 3 by 4 by and 0 is K. So the 3 by 2 by and 0 is 2K. So 2K multiplied VS squared multiplied 25 by 2 into 0.5 divided by 25 by 2. You got the starting torque is a KVS squared by 25 by 2. So this is for the starting torque. And previous one. KVS squared by 9.89 is a full load torque. So you have to make that comparison. So direct online starting torque by direct online full load torque. That way you make a comparison. KVS squared by 25 by 2 and divided by KVS squared by 4.94. So then you got the 0.4. So this is we got the ratio between the starting torque and the full load torque. Started starting. Started starting is a started starting torque is equal to 1 by root square multiply that direct online starting torque. So this is the equation. So then theta start delta is equal to 1 by root 3 square multiply theta TOS starting. Okay, so this is 1 by root 3 there. You want that? And starting torque is already calculated 0.4. So then we say 0.133 per. So this is for started starting is 0.133 of the full load torque. So this one is a TFA. So this means TSD is DOA is equal to 0.4 TFA. And similarly, the started starting, so 1 by 2 square multiplies the direct online starting. So direct online starting is 0.4 full load torque. So you got a 0.133 TFA. So this is for the started starting. And C waves are auto transformer starting. So auto transformer starting. So that wave the equation is a T auto. Is equal to percentage stepping. Square multiply with the T is the DOS starting. So this is the percentage stepping is already given. Auto transformer starting with 75%. So stepping. So this is a 75% is a 0.75. So 0.75 square. So direct online starting is a 0.4. So by solving this answer 0.4 TFA. So that way is a 0.231 TFA. Okay, you see that this is a problem. So depending on the kind of starting, so they are related to the starting torque and the full load torque relation we can see. The first method is reduced voltage starting. Reduced voltage starting means primary resistance starting. Primary resistance starting means that at the starting position, motor, induction motor we used to draw the higher current. So the higher current needs to be reduced. So what we do is we connect the resistance series resistor. So at the starting time, the motor is connected with the series resistor, and then for motor starting current we reduce. And then at the running time, those series resistance are gradually bypassed. So by the equation, this one can be executed by the automated starter. So at the time is starting, the primary resistance starting, the resistor is connected in each motor line to produce the voltage drop to the motor starting current. A timing relay start is the timing relay start to operate, and then the motor will these are all the systems will use a bypass. So by this way that we start the reduced voltage starting. Order. So this is RSC. RSC for the starting resistor. They are to be in series with the motor. So at the kind of starting, all the running connector must be in open and starting connector are S. So S must be in the close. So and then when the motor start, S must be open and run must be closed. So then the motor will get a pull. So that this control circuits are all perform the best function. So when we press the starting switch, so they are the stop. The 2, 3 is a stop switch. This is a start switch. When you press the start, so current from the 1 passing through the 2, 3, 4, 5, 6, 7. So then we reach the line. So then we use the motor we start. Motor we start with the start. So motor we start. So that this starter we get connected to the all the starting connector. So this is the S is energized. So S is the starting holding by energized. So the all S are the closed. So the motor we start. So the S and the RSC starting resistance are CD. So the motor we start with the reduced voltage because the RSC reduce the voltage. Okay. In the meantime, the SA also the SA are also the closed. SA closed means that SA is the oscillatory contact. Oscillatory contact in parallel with the start switch. So that you don't need to press the start switch for the all time because SA oscillatory contact is closed. So the motor will continue to run. And similarly, this SA is also closed and the TR holding coil is TR coil energized. So TR coil is try to close the TRTC. TRTC means the timing contact. TR coil is timer relay coil. So this timer relay coil try to close the TRTC. TRTC means the timer relay timing contact. So in this case, the TR is a timer coil. So timer relay coil. And then TRTC. TRTC means timer relay timing contact. So this is for the TRTC. Timer relay timing contact. So timer relay timing contacts are try to close, but TRTC will not close immediately because it waits for the some time. Because the timer contact means that all those coils energized, the contact will not close immediately. It waits for the some time. After some time, it will close. So that after some time, it will close, it will energize the running coil. Running coil energized, so that this running coil energized, so that the running coils are what happens is the running coil energized means that all the run connectors are closed, but this normally closed run connector is open. The normally closed run connector open means that the starting coil is no longer energized. De-energized, so all starting connectors are open. So this way, by this way, all the starting resistors are removed from the connection. So the running connectors are now closed, so the motor will run with the full voltage. So that this also the run to contact is also closed. So the timing contact also the bypass. So that we don't need to any more timer function. So this is why we operate. So starting connection. So all the motor will start with the resistance. The resistance is series, and the running connection. Those are starting connectors are the bypass, and then the running. So the running connectors are closed. So starting coil is de-energized, so the motor will run with the full line voltage. So this is the operation of the primary resistor, the automatic starter. And the starting times motors are windings are connected in star, and the running times motor windings are connected in the delta. So this is for the star delta operation. So this star delta important one is the star and delta connector must not close at the same time. So this means that when the star connectors are closed, delta connector must be open. So this means delta holding coil must not be energized. When the delta holding coil energized, star holding coil must not be energized. So in this case, the changing from the star to delta, you can use all this one relay. This relay for the two connectors. One is normally closed, another one is normally open. So normally closed and normally open are interrelated. So when the normally closed is the contact one is closed, contact 2 must be open. And contact 1 is open, contact 2 must be closed. That kind of switch is important for the starter starter. So that the star holding coil and the delta holding coil will not be energized at the same time. So now I give you the circuit for the starter connection. The starter connection. So in this case, you see that 1 and 2N, two are the contactor, and 1S, 2S. So this is for the 1S contactor. This is 1S. This is 1S and 1S. 1S means that 1S contactor need to be closed at the time of the starting. So starting time, it needs to close the 1N contactor and also 1S contactor. So 1S contactor need to be closed and the 1S contactor need to be closed at the starting. So starting time, 1M and the 1S closed. And running time. So running times are 1S has to be open. 1S open, so the 1 and 2N must be closed. The running time, 1 and 2N are closed. And the 1S open. So this is the operation sequence. So starting time, 1M must be closed and the 1S must be closed. And running time, 1 and 2N are closed and 1S must be open. So this is for the function. So this function is executed by the starter switch. So when you press the start button, so the current flow from the supply passing to the source start and the passing to the 1 area normally are closed. So this is for the, so it will pass into the 2N contactor. So passing to the source start and the A contactor. A contactor is normally closed. They are energized by the 1N. So they will go to the 1S. So 1S are closed. 1S closed means that all the 1S quite energized. 1S quite energized, so that all 1S contactors are closed. So this is the star contactors are now closed. And also, in the meantime, 1S closed means that the current also flows to the 1M. So 1M also energized. 1M energized means it can close the 1M contactor. Close the 1M contactor means that all 1M contactors are closed. The motor will start with the starting current. So this is what we start. Motor will start with the reduced voltage because the contactors are the star connection is closed. So the motor is connected is star, so the motor will start with the reduced voltage. And then after some time, this is it's also energized. 1M contactor energized. Okay, so then after some time, this is this B connection will close. Because this one is operated by the timer. Timer switch means that when the 1M try to open the A1M contactor, but it is not the change the position immediately because it is a timer for that. This 1M contactor try to open the A1M contact, but this one will not open immediately. Will not open immediately, it will wait for some time. And after some time, it will open. Then this opens, so this one will be like this. So this one will open, so this one, B1 and contactor is closed. So the B1 and contactor are closed, so this means the 2M coil energized. 2M coil energized means all 2M contactors are closed. In the meantime, this 2M normally is open, so 1A is energized. So this is where we work in. So this is A1N and B1N. A1 and B1N are the same trip bar. Touch. They are timer switch. Timer switch means that all those are 1M that try to open this one. This one will not open immediately. This is the timer. This is the timing switch. So that during the time, motor current is already reduced. Starting current is already reduced because of that. Normally motors start with a higher current, but the motor is speed up, the starting current is reduced. So during the time the motor current is already reduced. Then after that the 1M contactor is open. 1M contactor open, so the 1M A contactor is open, so the 1M B contactor will close. Close where 2M is energized. 2M energized means that all 2M contactors are closed. And 1S with 2S are normally go is open, so 1A is de-energized. So the motor wheels are run with the tensor connection. This is why we use. So in this case, we need the isolator switch, isolator connector. Normally, A1N is a closed position and B1N is an open position. But after some time, A1N is an open and B1N is closed. So this is why the ways of these are avoided and start and the stop switch are chosen together. So when the start switch is pressed, the current will flow through the source start A1N, 2M, 1SY. So all the 1S connectors are closed. So the current also pass through the 1Y. So also all the 1S connectors are also closed. So the motor start with the start connection. So 1SY is try to open the A1N contact. But it is closed. After some time, when the A1N is open, B1N is closed. So that 2MY is energized and all 2M connectors are closed. The motor runs at the tensor. The 2MY also open and normally close at 2M connector. So normally close 2M connector. So the YSY is de-energized and all the YS connectors are open. So this is ways we avoid the star and delta connector closing at the same time. Also transformer starter means that at the starting conditions the reduced voltage coil is energized connected, so the motor is start with a lower voltage. And when the motor is speed on, it's all this one off windings are bypassed and the motor connected to the full line voltage. So that one also can be the power supply the automatic transformer starter. So I will draw you the circuit. This is the operation when you press the start button, the current will flow from the 1, 2, 3, 4, and it passes through the line. So 1, 2, 1, 2, 3, 4, 5, 6, 7. So this is a 5, 6, and 7. So current flow from 1, 2, 3, 4, 5, 6, 7. Then another line. So because of this one, all the YS connector is energized. YS connector energized means that all the YS connectors are closed. So YS connector are closed. So this is also this YS energized, and also the passing through the 2S connector. So this means that 2S connector is also the 2SY is also energized. Then also 2S connector are closed. So YS 2S is closed means that motors are start with the reduced voltage because the auto transformer is included. And after some time, so this is 2S connector try to close and normally open connect 2S, but this one will not close at the same time. It wait for the sub time. After that, this one close. This one close means so one R connector is energized. R connector energized means that all R connectors are closed. So the motor is connected to the full line voltage. So this R connector open and normally close the connector at the alpha point. So the YS connector is no longer energized. So YS connector is removed. YS connector removed. In the meantime, YS connectors are also open, so the 2S lose the energizing, so 2S also removed. So the motor, so auto transformer is now eliminated from the supply. The closing of the 2S is also depending on the IELP. IELP means that this is the velocity operated connector. The velocity connector operator means that at the starting line, YS must be closed, so the motor with a reduced voltage. And after that, our motor must be connected to the full voltage. So this is the IELP is velocity operator switch. So release velocity operator switch means that when the motor starts rotating, this connector is closed. When the motor starts is strong connection, so this one should be open. So this is 2S only can be closed only when the motor is start. Motor is running. Motor without running, this one should not be closed. This is the velocity operator switch. This one also need to connect it to the 2S. This is why we run the motor. At the stop condition, motor must not be applied to the full line voltage. So this is why we provided this way. Motor only need to be applied to the full line voltage only in the running condition. This is when the start button is pressed, current flow from the 1, 2, 3, 4, 5, 6 and the end as a 7. So YS5 energized, so it flows all 1S contact. Then the 2S5 energized, so the 2S contacts are closed. The closing of the 1S and 2S5 energizes our transformer winding. So the percentage voltage. The percentage voltage is applied to the motor terminal and the motor starts with the reduced voltage. Then 2S5 close, the time delay contacts are 2S, then the R5 energized. So R contacts are closed, so the motor run at the full voltage. So then normally the contact point alpha is open. So 1S5 is de-energized and it's open, the 1S and 2S are contact. The transformer is removed from the supply. The velocity switch is attached to the motor shaft. So it is closed only the motor running die. So by this way, the motors are winding will not get the full voltage without running. So this is the auto transformer starter. So there are the three kinds of the starter. Primary resistor auto transformer primary resistor automatic starter, started automatic starter, and then auto transformer automatic starter. Those are the reduced voltage starter. So they are utilized to reduce the motor starting current and the motor starting voltage at the time of the starting. Because the induction motor starting they are drawing the higher current from the supply, so therefore we need to reduce the motor starting. So this is the way we can reduce. And another one way is that we also connect the motor winding. Motor winding can be the constant torque and the variable torque condition. Consequence for the starter. Consequence for starter means that we can change the number of poles. We can change the number of poles by the connection. And also, motor also got a multiple speed starter. Multiple speed starter means that we can change the motor terminal block connection, and then you can change the motor speed. So those are another kind of additional kind of the motor. So motor speed can be changed by selecting the appropriate terminal on the terminal bound. So those diagram I also need given. The motor connector here. So there will be the two-speed motor. So low speed and high speed. The supply lines are the low speed. So line 1, line 2, line 3 must be connected to T1, T2, T3. And in this case, low speeds are T4, T5, T6 must be open. And then, so at the high speed, the supply line must be connected to T4, T5, and T6. So there is no open contact. So T1, T2, T3 must be connected together. So by this is we can change the two-speed motor. So this is the connection we can change the motor. So that way we just difference of winding. The reason is that when you connect T1, T2, T3 connect together. So T4, T5, T6 are open. So that way the motor running with the one speed. So there's a four connection. Four connection we different. But high speed, that way there's another four combination. Actually, this kind will be the motor with higher number of poles. This one with the lower number of poles. So the two ways are change the motor speed. Low speed and high speed we can change by the connection. And similarly, this is the kind of the ways that we can change the pole changing. So the pole changing that we can utilize by the kind of the pole. So this is the starter can change the motor. Motor winding can be automatically changed by the starter. So starter are also utilized for the changing the speed. So this is for the electromechanical type. Another one we use electronic source start. Electronic source starter we utilize the SCR control circuit, the silicon controller rectifier. This silicon control rectifier, this one is the conduction depending on the gate firing signal. So depending on the gate firing signal amount, the conduction is changing. So the motor the voltage passing through the motor is changing the brightness of SCR, so the motor speed will be also changing. So that now I give you this one, the electronics that controls the SCR, the drive system. Here we call it like anode, cathode, and K. So this is the traveling connection. This is for assembly diagram. This is for low power. This is high power SCR. So when we use the SCR, we have to connect the circuit by this way. So this is for the here. This one adjuster, and this is the diode D1. The diode D1 is this is usually we use as a variant. This is the way that we utilize it. We have to reduce the voltage charge. So that's why it's connected to the SCR. So SCR. So anode, this is SCR, and the cathode, and this is K. So this one we use load. And so just connected to here. So this is SCR voltage. So 124.60 Hz. So gate firing signals determine the motor speed. So this is for the sinusoidal wave. This is for the gate firing. So this way the 25% output. So this is the late gated. And then we also use another PR, late gate firing signal. This is a half gated. So half gated. So output will be 50% output. And this is a fully gated. Fully gated means that this is the early gated. So this is early gated. So early gated is a 75% output. And then we use a fully gated. So this is 100% output. This is full voltage. This is full gated. Fully gated. So depending on the time to apply the path, the gate conduction varies. Gate conduction varies, and the motors also the speed also varies. So this SCR system we can also utilize for the three-phase system. Three-phase system is that you have to use and connect the SCR by this way. So this is a three-phase SCR drive system. So line 1, this is terminal 1, T1, and this one we use as SCR we connect like this. So this is line 2 and the terminal T2. And another SCR we connect like this. So line 3 and the terminal T3. So this is for the three-phase system. Three-phase motor system we use the SCR. So that depending on the SCR gate firing time signal, the output voltage varying. So by this way we can regulate the motor the speed. So about the starter. Starter means that the motor starting, motor usually draw as a higher current from the supply. So we have to need to provide a lower voltage. So lower voltage we can supply by the primary resistance starter or the auto transformer starter or the starter starter. The reason is that to supply the lower voltage across the motor terminal. So that those are we utilize the automatic starter to regulate the motor to change the switching. So this is for the electromechanical type the motor drive system. In the meantime, the starters we can also utilize to change the speed. So in this case, motor connection, on the same connection, there are 6 terminals. So by making the appropriate pair of the terminal, motor speed can be changed. So the starters are also utilized to change the motor speed by ordering the motor's terminal connection. So this is for the electromechanical type speed control system. In the meantime, we also utilize the electronic devices. So SCR means a silicon control rectifier. So silicon control rectifier conduction is depending on the gate firing signal. So when the gate time is earlier, so the firing will be earlier, so the motor will conduct the full conduction. So earlier, so when the gate conduction is late, the motor will conduct the higher lower voltage. So depending on the gate connection, motor speed will be the variant. So this is for the SCR connection. So this is SCR physical diagram and this is electrical circuit diagram for SCR. So here we use the TIAC. TIAC means we don't want the high potential. When you change this potentiometer, this is the variable resistor, the motor gate will suffer the starch. So this starch can damage the SCR. So SCR gate we suffer the starch, so it can damage the SCR. So because of this one, we utilize the TIAC. TIAC means that we can eliminate the potential. So that by adjusting the potentiometer, you can regulate the motor SCR case firing signal. So that motor SCR conduction is depending on the firing signal and the motor speed also will vary accordingly. So if you use the SCR for the three-phase drive system, we have to connect the SCR for that one. So this is for the power circuit. Then from the gate terminals are connected to the appropriate three-phase drive system. Then the motor speed will be vary. So this is for the electronic control system. If we draw a higher current, so data setting must be used for the SpeedControl machine. So that when you start the induction machine, induction motor usually draw a higher current from the supply. So this current needs to be reduced. So this is where we have to utilize the reduced voltage starter. Then for the three-phase induction motor, for the big motor we should use reduced voltage starting. Reduced voltage starting means at the starting time we provide less voltage to the rotor. So less voltage to the stator. So that by this way you can reduce the motor starting current. Induction motor they used to draw the current, the starting current will higher than about 2.5 to the sometimes up to the 5 times the normal full current. So this starting current need to be reduced by connecting the starting resistance. So that will be the primary resistance starter means that we connect the series resistor so that the stator circuit, the starting or direct online starting for the three-phase induction motor. For the big motor, we should use reduced voltage starting. Reduced voltage starting means at the starting time we provide less voltage to the rotor. So less voltage to the stator. So that by this way you can reduce the motor starting current. Induction motor they used to draw the current, the starting current will higher than about 2.5 to the sometimes up to the 5 times the normal full current. So this starting current need to be reduced by connecting the starting resistance. So that will be the primary resistance starter means that we connect the series resistor so that the stator circuit, the starting current will less. And also that we can connect the starter. At the starting time we connect the motor stator in the star connection, and running time we connect it to the delta connection. By this way you can provide the full load reduced voltage at the starting time and the full load voltage at the running time. In the meantime we also utilize the primary resistance auto transformer starter. So our auto transformer starter means that we provide lower voltage stepping at the starting time, so that by this way you can reduce the starting voltage, and then we increase the voltage at the running time. So this is for the reduced voltage starting method. So by providing the reduced voltage, we can reduce the starting current and we can also reduce the starting torque. So today's lesson is I will study the rotor motor. So rotor motor are different from the SpeedControl motor. Because SpeedControl motor got the rotor. The rotors are the copper bar. Copper bar they are put and they are welded together. So this is a SpeedControl motor. Because of this one, at the starting time, all the motor rotor is similar to all the systems connected in parallel. So there's a low resistance and this motor draw a higher current. But rotor motor is different. Motor got both the stator winding and the rotor winding. So at the starting time, we have to short circuit the rotor motor, slipping, and then when the motor is speed up, we need to gradually reduce the sliving, and we can connect the resistor. We can connect the external resistor to the sliving. So at the running time, by adjusting the load resistance, we can adjust the motor speed. So today the thing is that we will more detailed study the motor characteristic and motor controller starter circuit. So this is for the stator, this supply, and this is for the rotor. So this is supply, and stator, and this is rotor. So this is the external resistance. So this is for the rotor motor circuit. Supply, stator, rotor, and the external resistance. Then we also we can utilize the controller. So this is what I just said, zero set, but really we use a controller. Now I give you the next motor is a rotor motor starter with a controller. So starter controller with rotor motor. Fan controller, so the by controlling, so this is a connected resistor. By adjusting this one, all the three resistors, all the resistors connected to all three phases are simultaneously regulated. So by this way, you can adjust the speed of the motor. So the speed regulation is done by the resistance. So resistor can be used to regulate the speed if they should have the proper side. They should have the proper side and to prevent the overheating. So resistors are also used in the starting, but those starting resistors are used only for the short time. But for the continuous motor speed, we also have to utilize for the speed regulation. Those resistors are being used for the longer side. So because of the longer time, those resistors should have the appropriate resistance, appropriate side. So by placing the high resistance in the rotor circuit, so is it possible to start the motor and it produce a high starting torque with a low starting current. So this is why we use the resistor. By placing the resistor, we can also increase the higher starting torque with the lower starting current. So this is why we use the resistor for the both starting and the speed regulation. Yeah. So resistor can be used to regulate the speed if they are of the proper size to prevent the overheating from the constant use. The resistors used in the starting period are used only for a short time, but those used for the continuous motor speed reduction are in use for the longer period of time. So by placing the high resistance in the rotor circuit, it is possible to start the motor and produce the high starting torque with a low starting current. So the type of the starters are the multi-switch starter, crank controller, and the magnetic starter. So this is we use by the manually. Manually you adjust the resistance. But sometimes we also use the multi-switch. Multi-switch means the automatic switch. So automatic the conductor, those conductors are they are adjusting or removing the resistor by magnetic function. So by this way you can also adjust the appropriate resistance. Instead of the manual, you can use the sequence control or you just press the button and those are magnetic coils are we contact. So this is the multi-switch starter. So now I give you the schematic diagram for the multi-switch starter circuit. Starter switch. It can be the switch like this. So this switch. So when you see this one, we connect like this. After they are multi-band switch. Those are connected to the multi-band switch, so those starter switches can be switched. So by this way, we can connect the multi-band resistance to the rotor circuit. So that kind of starter is useful to we can use the motor up to the 2,000 horsepower and the rotor current up to the 1,000 ampere. So this is a very big motor we can start. So instead of starting it manually, we can use a magnetic starter. Magnetic starter means that I just mean that this is a connected this circuit connected like this. When this is a connected circuit, we connect like this. So this circuit connected to the multi-band resistor. So the two multi-band resistors starting, they are determined by the magnetic conductor. So magnetic conductor you can use a sequence relay or a timing control relay can be controlled. So this is for the multi-switch starter circuit. Controller for the starting and speed control. Starting and speed control we use for the crank controller. So crank controllers are similar to this one. They are you handle the both starter and the rotor circuit. It shows the whole rotor motor. Whole rotor motor means some of the loads are starting very heavy. Especially the induction motor, induction motor is normally the starting torque is poor, but when you start the motor, this is why when you are using any plant with the induction motor, starting times there should not be the no load, and load should be put on the motor after the motor has got the full speed. But in this case, not always possible. But especially the compressor motor. Compressor motor or reciprocating the compress. Similar to the car piston, the compressing. The compressing, every time compressing, then we use the force very heavy force. But after release, so at the compressing time, the force is the maximum, and this one go backward. When the piston go backward, then we force will use the minimum. So in this case, for the compressor motor, reciprocating motor, the compressing and the release times are the force are different. This time, force will be the maximum. Okay, so then this one release. Go back to this way, so this is force will be the minimum. The force will be maximum and minimum, so they are changing from the time to time, very frequently timing. So that kind of situation, motor is it can change the vibration. So in this case, square gauge rotor is not too suitable because we have to cannot be regulated. In this case, we have to utilize the one rotor motor. The one rotor motor is the most suitable to provide the most stable torque. And that kind of the pump motor or blower motor, reciprocating motor, back pressure. Most of the places are called the back pressure. In this case, we can utilize the one rotor motor. But one rotor motor is costly because of this is the more expensive. Because they call it both the stator and the rotor winding. So rotor windings are the cost is double times the square gauge induction motor. And also this one rotor motor called the resistor and the conductor. We need to make the periodic inspection. Periodic inspection means that all the time you have to make the check. Square gauge motor is very robust because this one does not have any movable conductor, so that you can use it as much as you like. But this one rotor motor, you need to check periodically. So they got this one advantage and a disadvantage. And similarly, square gauge induction motor. Square gauge induction motor is very robust. They very got the excellent properties for the speed above the 600 RPM. So square gauge induction motor is suited to use with a higher speed. But lower speed, it is not economical. So this is expensive. So also there's a lower speed square gauge induction motor can be heavy and low power factor and the poor efficiency. The one thing is that you can not easily control the speed of the square gauge induction motor. You see that this is the control system that some of the users are working. The control system is the input is a single phase. Single phase, the output is a three phase. So this single phase to three phase function is done by the switching circuit. But those switching circuits are complex, very complex switch. So that to drive the one motor with the variable speed, we need a very switching circuit, very many conductor, very big control system. So this is not always economical to run the square gauge induction motor speed control. So in this case, we use the one rotor motor easier because you guys just easily regulate the motor's rotor speed. You can easily adjust the speed. So if you want to adjust the speed, very widely adjustable. So in this case, you have to utilize the one rotor motor for the DC machine. So this is why that we use the DC motor in the railway system. Because railway system is train speed are very adjustable. So you need to be adjusted. So square gauge motor is not possible because you can't frequently adjust the speed. This is why we use the DC machine in the one rotor railway system. So the square gauge motors they are good property, but the speed regulation is the best, the minus for them. We use for the motor driven controller, less air conditioning and plant. They can start with the low and drawing without drawing too much current. They can be used for the low with the back pressure and also used for the small speed change. But disadvantage is a higher initial cost. 3-way brush and resistor switching arrangement and requires a periodic inspection. And otherwise, the square gauge induction motor. Square gauge induction motor, they can be utilized for the speed above the 600 RPM. But disadvantage means the speed control difficult. additional reduced current for its study requires for the big motor at a lower speed. It can be heavy, costly, and a low power factor and a poor efficiency. I talk about the Woodrow motor. The Woodrow motor starter method, free regulation, switch starter, and drum controller, and there's application of the cylindrical motor and square gauge induction motor. They have the advantage and a disadvantage. So this is one that in the industrial application that you need to select the appropriate motor for the appropriate driving state. In the meantime, you also need to justify your benefit and the cost analysis. So as you say that I talk about the motor speed control. After that, I will continue with speed control by the frequency changing method, and also standard jogging, plugging, and braking. Jogging means the step-by-step movement of the motor, especially we use for the crane motor. Braking, plugging means that instant. We want to stop the motor instantly, so those methods are the braking method and the plugging method. So those methods and the automatic starter utilized for the those methods are we use 8 blades. You can see a speed control method. We use as a solid state starter. So the incoming voltage is AC voltage. So we use a rectifier. Rectifier we convert it to the DC. And then this DC voltage put into the inverter. Inverter is switching circuit. Switching mode circuit and switching speed can determine the output frequency. So this variable frequency is produced by the switching inverter. So the more about the switching inverters I will be teaching in the next semester. The H25 and 26. So Sanskrit we have finished in the next last semester. So this is for this more unique mostly focus on the switching speed starter, switching speed control. So then now I just give you a brief in description. So switching speed means that incoming is an AC voltage. AC voltage is rectified to the DC, converted to the DC by the rectifier, and the DC voltage is fed into the switching circuit. The switching circuit they switch that circuit so that the switching frequency determines the motor frequency. And so this means that we can also use the power with a modulated switching system. The switching system power with modulator, we can create the artificial flyway. So that kind of control system is utilized for the solid state motor control. So then I give you the schematic diagram for the switching circuit and also the controller of the SCR drive system. For the schematic diagram. So solid state AC motor control is accomplished by the changing the frequency of the power source. The motor speed adjusts by the controlling the output voltage frequency of the unit. So incoming AC voltage, so rectifier change to DC, inverters are changed to the inverter. So this is the adjusted frequency. So the adjusted frequency set to the induction motor, so we can achieve the variable speed. So this is the variable speed drive system. So we use that variable speed drive system, especially for the food packaging plant, paper mill, cement plant, centrifugal plants, blower. So those ways we use the variable drive system. Now we use the SCR. SCR means the SCR or the tri-S or di-S. They are the digitally controlled switch. So for example, this one is a 120 volt AC. We supply, and this one will be a variable resistor. Variable resistor. And this one is connected to the capacitor to produce the charge, and this is a tri-S. The tri-S is connected to the this is a tri-S. So this is a tri-S. The tri-S is connected to the load here. So this one will be a direct control type. So variables are firing, scaling is controlled by the variable resistor. Variable firing current. So this is a firing current. Firing gate current. is controlled by variable system. So by this is how we can control the speed of the AC motor. AC motor speed we can control by the circuit. So the circuits are when you use this one here, we use the low speed are ready. So starting at the low speed and then switching to the higher speed. And also the automatic sequence are calculating really. So sometimes are the starting, so the running time. This is performed by the sequencer. The sequencer is also included in the motor starter. And also sometimes the motor you have to utilize the motor is subject to the larger load. In this case, motor speed need to be slow down. So also we can utilize the automatic sequencer decirculating really. So those kind of the motor we need to protect low voltage protection. So when the voltage is low, so we need to cut out the motor from the supply. And also the time delay protection also is required. Time delay protection means the sometimes our motor is we can draw out the motor on the low voltage, and when the actual voltage is normal, in this case it's better reconnect the motor. So this is what we can utilize. So that those electrodes are they are the solid state equipment are more accurate, but they got the disadvantage. Disadvantage means that sometimes electrical spike can easily damage the solid state equipment. Yeah, because of this one, when you are using a solid state equipment, we need to suppress the charge. The charge suppressor or the lighting protection are the important for the solid state motor control equipment. We have need to protect protection. When we utilize the solid state equipment, so they are not suitable for the voltage spike. Voltage spike or the voltage surge can damage the solid state equipment. So especially the voltage surge can happen created by the coil. Because the induction motors are coils. The motor coil can easily create the harmonic and the voltage spike. Those voltage spikes can damage the motor. Because of this one, we have to utilize a surge suppressor. Surge suppressor means any switching surge need to be suppressed. And also lightning protection equipment also need to be utilized. So this is important for the motor protection. Other side is a voltage rating. So the lightning voltage 2,200 volts. So in this case, current rating is 1,500 ampere. The 5,000 ampere is 2,900 volts. 10,000 ampere is 3,400 volts, and the 20,000 ampere is 4,000 volts. So those are the surge elector and the lighting protection. So lighting protection and surge electors are important for the solid state motor drive system. In the motor power system, motor electrical drive system, we are increasingly using the solid state control. So because of this one, we need to limit the surge. So when the solid state controls are utilized in a circuit, and then has the electromagnetic devices, and they are the problems with the power source. So such suppressors are utilized to limit the voltage transients for the application requiring interface with the solid state component. So this is the motor protection. So motor protection requires for the protection against the low voltage and time delay protection, lighting protection, and the surge suppressor. They are the additional equipment to the properly protect the solid state and the motor drive system. So this is the application I'm talking about the motor speed control and the solid state drive system. Then I will continue to talk about the Georgian plugging and the braking. Georgian means that not always motors are running at the full speed. Sometimes you need to slow the speed. Sometimes you need step-by-step movement, especially for the crane motor. Crane motor means the crane is moving backward and forward in the midnight step-by-step movement. So that kind of movement is we call it forward reverse moving, and also the Georgian method. Sometimes the motor needs to be instantly stopped, especially the crane motor. When you want to stop the motor should be stopped at the same time. This is why we also need to utilize for the immediate stopping system. So there are two kinds of immediate stopping system. That will be the plugging and the dynamic braking. So those are methods I will explain with the diagram now. Okay, this is for the Georgian system. Georgian means the momentary operation of the motor from the rest for the purpose of the accomplishing the small movement of the driven machine. So this is a little by a little movement is a jogging. So that now that this jogging that we can connect the control circuit for the jogging. So how we control it? This is a line one. For the line one, and this is a stop. And this one is connected to the start switch. So start switch. So then we use the this is the A. So this one is connected to the holding coil, and this one is motor N. So this is the overload, and this is for the line 2. So this is for the typical jogging system. Jogging system means the run and the jog. Run and jog means, so this is for the A2. This is A1 and the A2. So call it the A2 and the A1. So in this case, this is 1 and 2 here like this. So that if you put the A1, one position, the A2, if you put the A1 on, then we use the motor will be jogging. So when the A2 is on, then we use the run. So this is for the sequence switch. Sequence chart. Sequence chart means that A11 means that A1 is the switch on. So in this way we can do the jogging. A21 means that A2 is on, then we use the running. This means that you see A2 off, A2 is a 1 means that A2 is connected in contact. Contact means that this one is closed, so that when you start the motor, the auxiliary contact will be closed, so that you don't need to press the start for all the time, motor will run continuously. And when you want to make the job, so you have to switch out of this one. So this is the A1 contact must be made. So A1 is a 1, so A1 is a job position. So this circuit is off. This circuit off means the motor can only run when only with you press the start switch. So this is why that we use the starting and the jogging. Jogging and the runs are this control circuit. So this one also we can integrate it to the starter circuit. So on the full starter circuit, we can integrate. So this one is a run and a jog function. So this run and jog function we can integrate it into the full starter circuit. So there is the A1 here. So this one is the stop switch. Stop switch. So there we use the start switch. And then this one is connected to the CR. CR is controller relay, and this is a holding by N. So this one connected to the CR. And then this one is connected to the jog function. The jog here, and this is a control relay. And control relay is connected to the M function. And this one connected to the overload. And then connected to the line 2. So line 1 like this, we connect like this. So this is for the starting and the jogging complete controller circuit. So when you press the start switch, so when you press the start, so motor will run. So motor will can control relay will close, and the motor will run. And when you press the jog, so this is on the start switch. But when you make the jog, only we press the jog. By pressing the jog, so this motor will run the step by step. So this is for the jogging function. So starting and the jogging. So this starting and jogging you can also utilize for the forward reverse starter. So I give you the forward reverse starter, jogging and the starting circuit. Jogging circuit utilized for the forward reverse starter. So when you press the start, so the CR energized, so CR will close. CR will close and but the M, so this CR only close. But when you, in this case, you have to press the jogging switch. Jogging switch on, so we start the motor, so this M also will energize. So M energize, so the motor will run. But only you press the start, so this is we can run by the jogging. So this function this is for the only one direction, there's a movement. So when you press the start switch, the CR will close. So this CR also close, so that the current will flow to the end. the motor and also close. All the MSC are closed, the motor run with the continuously. But when you on the stop and you only press a jaw. When you press a jaw, so in this case, CR cannot press. CR cannot be closed. Because if you don't press the start switch, only you press the jaw switch, CR cannot be closed. So CR cannot close the motor, only we run, only when you press the jaw switch. So this is for only one direction. And then one is that you can run by the two directions, forward and the reverse. So start forward and start reverse. When you press the start forward function, so all the F connects are closed. F connect closed, so the motor FY energized. So the FY energized. In the middle also the CR connector also energized. And the CR connector closed, so the motor running into the forward direction. When you press the start switch, the always says the R connector is closed. R connector closed, CR connector closed. So the R quiet energized and the motor running with the reverse direction. But you cannot press the start forward and start reverse at the same time where you use the interlock. Otherwise, motor will use the blow up. So this is the interlock mechanism. So when you press the start forward, you can't press the start reverse. When you press the start reverse, start forward automatically use the release. So this is the way you protect the motor. And then the jogging function, the jogging forward and the jogging reverse. When you press the jogging forward, this quiet close. So the CR will no longer get the electricity. So that you can only run the motor only when you press the jaw forward. So only FY is energized. Only when you press into the jaw forward switch. And similarly, jaw reverse switch you press, so this one is off. This one off in the CR no longer get the electricity. So that therefore you can know that also the bypass switch. You can only motor will run in the reverse direction when only when the jaw reverse switch is closed. So by this way you can provide the jogging for the forward reverse starter. So forward reverse starter we use with the jogging method. Jogging is a little by a little movement. The forward and reverse is a continuous movement for forward direction and reverse direction. Jogging is a little by a little movement for the forward and reverse direction. So the jogging circuit is utilized for the crane control system. Crane control need to wait the forward and reverse a little by a little movement. So we use the jogging with the forward reverse starter. For the plug-ins theory, if you start breaking in with the motor connections are reversed. So this is the plug-in means that as soon as you press the stop button, motor connection need to be reversed given the reverse direction current. So this reverse direction current will instantly stop the motor. As soon as the motor is stopped, we need to cut off the supply as soon as possible. So this is the way we immediately stop the motor. So the essential breaking in which the motor connections are reversed so that the motor develops in the counter top. The motor is right in the one direction only and must come to complete stop when the stop button is pressed. The reverse connectors of the reversing switch are used only for the plug stopping and not for the running in the reverse. So this is the reverse direction only for the just for the stopping. They are not designed to run the motor for the reversing period. So in this case, as soon as the motor is stopped, we also need to attach with the speed switch. Speed switch means the speed switch is closed only when the motor is in running. As soon as the motor shaft is closed, motor shaft is stopped, the speed switch must be open. So the speed switch is in the series with the reverse. So that way that we can prevent the reverse direction movement of the motor. So this circuit I can given and we explain. Diagram. Firstly, there will be the forward. Forward positions are when you press the forward switch. So this is the forward. Forward and the reverse. So this circuit is a common circuit. This circuit includes the forward, reverse, running, jogging, as well as it also includes a plug-in system. So when you press the forward switch this one for forward is pressed, so the current will flow from the 1, 2, 3, 4, 5. The forward quite energized. Forward and quite energized, so the motor run in the forward. So that this is this one open. So this one open, so the reverse side will not get energized. So the motor will run the forward. Forward got energized. So forward got energized means that control really F is closed. So all F folders are, this F folder is open. So F open means that this motor is the passing through. The passing through that this CR is energized. CR energized means that all CR folders are closed. So that you don't need to press the motor for the die, so motor will run. So this is the forward. And reverse for the chain. So when you press the reverse switch, then will the current also flow into the 1, 2, 3, 4, and the 5, and the forward circuit is cut off. Forward circuit cut off, and the reverse connection will energized. So that the current will flow from the FR, beta, CD. So this is the reverse. So this reverse connection says the CR energized. CR energized, and the current also flow into the 6, 7, 8, 9, 10. So that this reverse wire energized. The reverse wire energized, so the motor will run in the reverse. So because of this one, the R connect open, so the forward side cannot be energized. So this is where the motor can run the forward and the reverse. And when the motor runs forward, so that this is the after that you want to stop the motor instantly. So after you press the stop, and then you have to press the R. So this is called forward plug-in. Forward plug-in means that you press the stop, and you have to press the F. So as soon as you press the F, stop means that all the coils are de-energized. As soon as you press the F, so this means that this coil is this one is this R connector is energized. This R coil energizes the motor instantly to scan the opposite direction. But opposite direction means this coil is a lock-out solenoid. This lock-out solenoid only is operational when the motor is running. This means that this switch R and this plug-in switch are only operational so long as the motor is running. As soon as the motor is stopped, they are no longer operational because of the lock-out solenoid. Lock-out solenoids are cut off the supply to the motor. Although you continue to press the forward plug-in or reverse plug-in, motor will no longer be running. So this is the way we go. So that for the plug-in, you need to press the stop, and you need to press either forward plug-in or reverse plug-in. You run the motor in the reverse direction, and you want to stop, you want to press the stop switch and reverse plug-in. When you are running the motor in the forward direction, you want to stop the motor, you want to press the stop, and you want to press the forward plug-in. So by this is the motor will stop instantly. But those are the plug-ins switch is only operational. They are controlled by the lock-out solenoid. So they are only operational so long as motor is running. As soon as the motor stops, they are no longer operational. And this is why we prevent the motor to turn into the opposite direction for a long time. This is ways that we are applying for the forward, reverse, and the joining system. So this is for the forward running and reverse running. So forward running, press the forward switch. So current flow from the ABCD. So this is the ABCD here. And the CI and the JI. So this is the current flow from ABCD and CI is energized. So CI energized and CI connectors are closed. Then current flow from the CI connectors to 1, 2, 3, 4, 5. And there's FY energized, and this is normally closed as it open. So motor run with forward, opening of the normally closed S prevents the R going to energize. So this is for the motor we running in the forward. And this is reverse running. Press the reverse switch. So press the reverse switch, you press this reverse switch. By pressing the reverse switch, the current flow from the FR, beta, C, D. So the CR is energized. So CR energized, so the CR connectors are closed. The current then will flow from the 6, 7, 8, 9, 10, and the R is energized. So this is the normally closed R in series with the S is open. So the motor will run in the reverse. The opening of the normally closed R prevents the SY to be energized. So this is we run the motor in the reverse direction. Okay, so to stop the immediately points are running the forward. So in this case, you have to press the stop and the F plus switch altogether. So the R will be de-energized. So this is R will be the de-energized. So the when we use the energize to the motor, try to turn the motor in opposite way. As soon as the motor try to turn opposite way, motor will stop immediately. And after this, long out solenoid deactivated flat connector, so the motor will not continue to run in opposite direction. And to stop immediately find the running rubber. So you have to press the stop and the rubber plus switch all together at the same time. So the F5 will be energized and try to run the motor in opposite direction, then the motor will stop immediately. So this is ways that we run the motor by forward rubber and the plug-in operation. So that means also we can use the brake. Brake is there are the two kind of brake. One way is the mechanical brake. Mechanical brake means that you can use the motor running. These are the grid as a brake squad at the same time. And another one we use electrical brake. Hydraulic brake. Hydraulic brakes hold the brake right at the same time. And so this another way also uses the electrical braking system. Electrical braking system means that when you are motor running, as soon as you press the stop switch, we provide a DC current. So DC current flow into the motor, so the motor will stop immediately. So this is why it's three kind of braking. We use a mechanical brake, electrical brake, and DC supply brake. So there are three systems. So regarding the brakes, I told you that one story. The times are that I never work for the South Yard, so in the Burma. So in the times are that we control the motor, very big DC motor. DC motors are controlling the electric range. So the motor is when you press the motor control, normally the motor shaft is hold by the brake. So this is the motor here. So this is for the shaft. So we use this is the brake here. So this is the brake one. Brake shoe and this is a magnet. So this is the motor. So as soon as you press the controller, as soon as you press the step forward direction, this one is normally hold the shaft. This motor, this brake are normally hold the shaft. So the motor cannot rotate. As soon as you press the forward direction, this magnet is energized, so this one will release. So that this motor shaft will release, the motor will rotate. As soon as you press the stop, this one will hold the motor shaft. So by this is we control the electric crane. Electric crane is the brake system. Brake system is when you are running system, they should release, the motor shaft can run. As soon as you stop the motor, this one will hold the shaft. Okay, that time we run the motor, so this is a very big DC motor running. What happens is the motor is very hot. Motor very hot, so that we go and check everything. All the electrical connections are correct. Everything, nothing wrong. Because normally motor hot is that you think the motor is burning. So we got to start some smoke. But when we are running the motor is good. Nothing wrong with the motor. And after that, what happened while we saw the motor, we run. Motor can run. Motor run, and then after what happened is that after the 10 or the 5 or 10 minutes, we get a smoke. So the motor is very hot. Motor hot we saw, and the motor is alright. So another 10 minutes, 20 minutes, motor cool down, and we run, motor run. So what happened is this motor is running. So this is the shit is that the carry the cable lock. Cable lock the carry, so that this is a very tight, is a very close. Has a must do that fit it. So that times are there. We check that all the circuit, everything. So the whole night we work. So that after the morning about 3 a.m. we found a fault. The found a fault is this controller circuit. This controller circuit is terminated loose connection. Loose connection means that this one will not release. When the motor runs, this brake is holding the motor shaft. Just this one also rotates. Rotate means that this brake is catching the liner and this called the hole. So that this hole is go to the motor is hot. This brake is problem. This brake is didn't release. Didn't release when you run the motor hot. So this called the high pressure in the motor hot. When you stop the motor, the brake is stopped. So then motor will cool down. So this is the electric are the ones connector. That connector is the system that you use a full length wire. So this connector is very very loose connection. Loose connection means normal we can see, we open the controller block, we check everything, but they are very loose connection like this. So we can see by eye. Finally, we test it, so we found this one is a very loose connection. So this guy, we have to join this wire, so model we run that currently. So this is my experience. So this is a mechanical brake system. When you are running as a mechanical brake system, sometimes brake will not release because the control system may functioning or disconnection. So due to the effect, motor will be overheating. So if you continue to run, finally the brake will melt down and the motor can also be burned. So this is the disadvantage of the mechanical brake system. So the mechanical brake system is widely utilized, but sometimes we need to check the brake circuit system. So then now today we use the electrical brake system. As soon as you press the stop button, so there's a DC current need to be applied to the motor, and the motor will short immediately. This is a dynamic braking system. So you use the rectifier the DC circuit. As soon as the motor is short, we provide this dynamic braking, so DC circuit to the motor. So the motor receives the DC supply and the motor will short immediately. So this is just a very basic diagram, but the inaccuracies are there for the most complicated one. So the advantage means that no friction. So as I told you that mechanical brake is that this is a friction. Friction means that all the brakes are there for the machines are sheet, machine disc. This means that this is brake here, this is brake, and this is spring, and this is for the body magnet. So between magnets we have to use a machine sheet. Spring tension needs to be adjusted. There's a machine sheet are the distance, adjusting the distance between magnet and the brake shoe. So this is very important because when these machine sheets are there, they are not appropriate size, brake will not operate. So there are a lot of machine sheets are too small. In this case, brake is too tight. Can happen. So this adjustment is very technical. So they are very usually sometimes you have to guide the machine sheet one by one, and then we get adjust. So this is very important for the mechanical brake. Sometimes mechanical brakes are they hold by the pinion, hold as a brake shoe. So sometimes this one case is wearing can happen. Yes. So once the brake is sometimes brake damage, especially the very heavy loss are used by the crane. Once the brake heavy, the whole lot of fall into down, the people can die. So some people walk and die by this way. The brake is a very dangerous. So because of this one, now we need to utilize this electrical brake. Electrical brake we can avoid that kind of problem. But only important one is the electrical brake system. When the power fails, we can run an electrical brake. So this is the things are true. The power must be present all the time to be the operational for the electrical braking system. Dynamic braking of the AC induction motor is suddenly accomplished by the exciting is the stator winding with the DC current. The amount of the braking torque is directly proportional to the DC current passing through the stator winding of the motor. So as soon as you press the socket, we need to apply the DC current to the motor stator. So the motor will be short immediately. So advantage and no friction, wear or the maintenance it can be adjustable, and also the short start capacity. So disadvantage means the electric motor brake will not stop the motor if the power is lost or the disconnected. So alternatively, we can also utilize the mechanical braking. So electromagnets pull the brake shoe away from the motor shaft wherever the motor is energized. So in this case, the magnetic brake. So require torque to stop the motor is the brake torque. Brake torque can be calculated. The formula is rated horsepower multiplied 5252 divided by rated RPM. So this is for the brake torque calculation. So we also utilize the hydraulic brake. Hydraulic brake says you can put the foot feeder so the hydraulic reservoir coming here to the reservoir with the hole that motor shaft. So hydraulically apply the shoe that the brakes are utilized. They are used for the crane, traverse, advice, all machines, and the conveyor. So we use the hydraulic brake. So the two, as you just said, I talked about this braking system. So dynamic braking system, we either use the electrical or magnetic or the hydraulic system. So So this is the motor stopping system. The motor stopping system that we use either plugging or the dynamic braking. Plugging system means that when you press the stop button, the motor's supply needs to be reversed. The dynamic braking that when you press the stop button, motor data needs to be applied with the DC circuit. So DC stop the motor immediately. Okay, last week we talked about this